Okay, now we're going to go over some advanced strategies. You don't need to know all these, but they come in handy. Sometimes you get your problem done a little bit quicker. And it's just nice to know how to do these different methods because it just reinforces more ideas in terms of algebra. So you'll see why I'm doing this in a second. But on both of these, what I want to do is I want to get my y all by itself. So on this one, what could I do to get the y all by itself, do you think, on this left side here? Any suggestions how you might be able to get the y by itself? Nobody? Okay, what you could do is you can just take this x right here and subtract it over to the other side. Some people want to think of it as a 1x, which is fine as well. Subtract that over to this side. And then you're going to have positive y, same as y, equals to 13 minus 1x, or you could say negative 1x plus 13, same thing. Okay, so then if you could do something similar, you could get the y by itself on this side. Any suggestions of how we could get the y by itself on this side?
Do the same thing you did there, subtract the 9x.
Yep, you could take this 9x right here and subtract it over to the other side. And remember, you want to keep it balanced to keep this equal, so if you subtract 9x here, you're going to subtract 9x over here. And technically the y is not by itself because we got a negative there, so any ideas what we could do to fix that?
Divide everything by -1.
Yep, divide everything by -1. Or you could multiply everything by -1. Accomplish the same thing. Then when you do that, you'll have a positive 1y, positive 9x, and a negative 77. So now what we could do is we could look at this one and this one right here. Can anybody think of a way of how you would integrate those two together? Or nobody? Yep.
Do you make it like the other problem, like put a, like move it over, and then do what you do for
Stack them on top of each other. Okay, so take this one and bring it over here. Okay, any ideas from there?
Multiply something like, or just cancel one of them out.
Yep, your way would work better if these were equal to a number. So what I'm going to do, because they're both equal to y, so if y is equal to this, and if y is equal to this, then shouldn't that mean that this and this are equal to each other? If you guys are able to see what I mean by that. They're both equal to y, so if they're both equal to y, they're both equal to each other as well, right? Okay, so then that means I can set up an equation that looks like this. 9x minus 77 equals 13 minus 1x. And this right here shows you why I like doing the elimination method better, the way that you were trying to get me down. The only reason I didn't do that is because we did that on the last problem, so. Just trying to show a different way that you could solve these. And from there, if you chose to do that, and if you could do it this way, you've got a pretty good understanding of algebra, which tells me that you would be able to solve for x on this just fine. So then what you would do once you found your x, you'd go back and you plug it into either one of those two original equations from there.